Ever wonder what makes a scale model rocket not just soar in the sky, but return safely back to Earth? It's not just about thrust and altitude, it's about smart recovery.
You don't want this, so how do we stop it? Meet the barometric altimeter that controls the black powder explosion and subsequent parachute deployment.
The GPS module comes in.
Is that the rocket?
Silly cameraman, we don't have a GPS module installed yet. I wonder where it could be. And now, the star of the descent, the parachutes. Deployed at just the right moment, they slow your rocket's fall from terminal velocity to a safe, soft landing.
To make sure your parachutes deploy and you have a safe and successful recovery, you need to do a black powder test. Here we go. Bringing it all into the avionics bay, with these electronics, the black powder charges, the parachutes. We're ready for a safe and successful recovery.
Come over, we see a event, there it is, drogue parachute.
And just like that, you've had a successful launch and are ready to recover your rocket.
Alright, so this is the whole demonstration of the av bay. So starting with what we have here as components. So we have the two 9-volt batteries right here, and we have the two screw switches as well as a guide, and all this will be for the altimeter. There's supposed to be two altimeters, but for competition we had to borrow one of our mentors' altimeters, so that's why there's not one here. And so all of these things will be wired on the terminals of the altimeter as well as the ejection charges. There will be ejection charges for the booster as well as the main. So the booster section would be the drogue and so on. For the screw switches, we have a guide over it because when this is all encapsulated, you can't really see where you're gonna put the screwdriver in. So we have this little guide with little grooves inside, as you can see. And this just helps us align the screwdriver well enough to go into the hole. So now, talking about the GPS. The GPS here will be connected before we put the coupler tube over it, such that everything will be wired and on. And this will connect to the receiver right here. And so the receiver, it's a little bit finicky. We typically got it to work when it's some distance away from it, and usually what it would show on the screen is a set of coordinates that you can input into something like Google Maps, and it'll tell you the coordinates of where the rocket will be. Alright, so this is the parachute demonstration. This is the main parachute that will be deployed at 600 feet or 500 feet, depending on if the main altimeter or redundant altimeter goes off. This is the drogue parachute, mainly used for stability, and this will be ejected at apogee. And so these parachutes will both be attached using our Kevlar shock cords, and they'll be tied on to the ends of the parachutes here, and they'll be going through these U-bolts. So they can either be knotted on, so just tying a bunch of knots on this U-bolt and this link right here, or we can use quick links, which basically allow us to quickly just hook on this parachute on right here, and then hooking it to the U-bolt right here, and twisting it and closing it, and they'll be all set and done. So for the ejection charges, we're going to be running 2 grams of black powder and 3 grams of black powder, and if those fail, we'll have redundant charges of 3 grams and 4 grams respectively.
Here we are on the launch day, setting up our avionics bay once we've made sure that everything is programmed as intended. Here we are, finishing up the assembly of the avionics bay while the rest of the team works on finishing their sections. As expected, this is a group effort, and as such, we tried to keep it all together. Before doing any launch, it is important to do a black powder test. With the black powder test, these are placed at the points that they will be in during the actual launch. However, the vehicle's body is kept on the ground. With the vehicle body on the ground, we then allow these charges to detonate to ensure that any shear pins that may be connecting body parts together will shear based on our calc. With a successful black powder test, we then connect the proper charges and get it all ready for the actual launch. The rocket body is assembled by all teams and then it is carried to the launch pad. It should be noted that recovery electronics are not armed at this point. Therefore, altimeters have not been turned on. Instead, we keep them powered off until the rocket is set upon the rails. With our rocket fully assembled on the launch rail, we can take a long, slender screwdriver and using the screw switches and their guide that was mentioned before, arm them, and then listen for the beeps to indicate the battery voltages on each one, as well as the frequency that they are at. With a successful launch as seen prior, we're able to prove that our parachute calculations, our black powder calculations, and all the electronics that we set up worked perfectly